Hi, today's lesson is on multiplying and dividing radical expressions. We're just going to cover multiplying in this video. I'll do a separate video for dividing so it's not as long. To multiply and divide, we're going to need to remember all the skills that you learned when simplifying radicals. All of that will apply when we multiply and divide. The first thing you need to learn is the product of radicals rule, which basically says if you take the root of any letter or number times the root of another, then you simply multiply the radicands. So the square root of a times the square root of b is equal to the square root of a times b. Note, to do this you must have the same index, so you must either both have square roots or cube roots, etc. First example here, the square root of 6 times the square root of 24. If we multiply those together, we get the product of 144. 144 is a perfect square, so the square root of 144 would simply equal 12. But note that A and B must be real numbers to use this property. Remember that we get non-real numbers when we take an even root of a negative number. So we want to make sure that if we were to see the square root of -6, then that answer would just be non-real, because the square root of a negative number is non-real. So don't continue to simplify it. Next, we're going to work through some of these. The first being the square root of 2 times the square root of 8. When we multiply these together, notice they're both square roots, so it is okay to multiply. I'm going to multiply my radicands 2 and 8 together. That gives me the square root of 16. So the square root of 16, since 16 is a perfect square, we know that is 4. Next, we have the fourth root of 4 times the fourth root of a -4. So your first inclination might be to go ahead and multiply the 4 times -4, but you need to be careful and recognize that we have an even index of a negative number, and this part here is not real. You will learn in Math 3 how to simplify that. Since part of the expression is non-real, then the entire product cannot be multiplied, and we simply need to state that it's not real. Next, we're going to look at the cube root of -5 times the cube root of 25. Note, we can take an odd root of a negative number. That's perfectly fine. That's different from up here. So that is okay. So we do want to go ahead and multiply these together, remembering that in our product we want to be sure to keep the index the same as it was in our original expression. -5 times 25 is -125. Or what you're going to have to do now is continue to simplify. So if we know that, by the way, to get -125, we multiplied -5 times 25, we can recognize that 25 comes from 5 and 5. Please remember that I told you that when you take an odd root of a negative number, the easiest thing to do is just stick a negative out front and not worry about it any longer. So now we can just say 5 times 5 times 5. Of course, 125 is a perfect cube, evidence in the fact that 125 is the product of 3 5s. So therefore our answer, this 5 would come out, and our answer would simply be -5. Next, the cube root of -16 times the cube root of 4. So when I multiply this, I have a feeling I'm going to have to simplify this, because I may be able to form groups of at least 3 of the same factor. So I'm just going to write -6 times 4 in here and break these down. Remember that with the negative, I'm going to put a negative out front and not worry about it anymore. 16 is the product of 4 and 4. So the shortcut is, if you recognize it's 4 and 4, then you've got 4 times 4 times this 4 here, which is a perfect cube. Makes it a perfect cube because you can form one group of 3s. However, you can continue to break that down. Each 4 is 2 and 2. Remembering that finding a cube root means finding groups of size 3 of the same factor. So I'm going to have negative 2 times 2, and I don't have to put the cube root because I don't have anything left under my radical. So I'm simply going to have negative 4. So if you'll take a look at this next slide, I've got some work up there to show you as well to help you. If you do print it out, this work would be on the PowerPoint. Let's see. Next, I want to skip over E. I meant to put that on a different slide, and we'll go ahead and do problem F. So I want to take a look at doing one with variables. Once you have this written down, what you should recognize is that with variables, if you have this same variable, you need to remember from your laws of exponents that we add the exponents of like variables. So I'm simply going to write 27 times 4 because I know I'm going to break it down. But I am going to recognize that I have a to the now 6th power and b squared. When I begin to break down my 27 and 4, 27 breaking down to 9 and 3, I know that 9 breaks down to 3 and 3 also. Copy this 3, and 4 breaks down to 2 and 2. Now if I want, recall that you can write out your 6 A's and also your 2 B's. Because we are finding a cube root, we are still looking for groups of 3 of the same factor. So I have one group of 3's, 2 groups of A, and I cannot form any more groups. So I'm going to leave the cube root of anything that's remaining. So I'm almost through here. Remember, you don't want to leave anything to the first exponent, so 3a squared times the cube root of 2 times 2 is 4, and b times b is b squared. And that's going to be my answer. You can type this in your calculator and verify the cube root of 27 times the cube root of 4, hit enter, then type in 3 times the cube root of 4, and that should be the same. And we are going to go ahead and stop right there with multiplying.